Hello to all. Today we are going to learn how to calculate speed and velocity. Now speed and velocity both have the same equation, and that's going to be v equals distance over time. Now in some cases you could see it as s equals distance over time. This is where, of course, s stands for speed and v stands for velocity. And this is distance over time, where distance is always measured in meters. And time is always going to be measured in seconds in order to use this formula properly. Remember that the main difference between speed and velocity is velocity has to have a direction. This has to do with scalar and vector quantities. So if you don't know what a scalar and a vector quantity are, make sure you go back and read over the PowerPoint. Maybe look at some of the websites from the WebQuest so you can make sure you understand those differences. So for our first example, I'm just going to write our formula up here. Velocity equals distance over time, or speed equals distance over time. It says Steamboat Willie drove his boat 1,200 meters. And of course, that's going to be our distance in 6.7 seconds. What is his average speed? Now, just a fun fact for those of you who don't know who Steamboat Willie is, that's the first original Mickey Mouse. So Mickey Mouse was kind of originally named Steamboat Willie. One thing that I like to do when I solve problems is I like to line up my variables. So here it's asking for his average speed. So in this case, that's going to be v. In terms of distance, it gives us a distance of 1,200 meters, and it even conveniently tells us here, hey, this number is your distance. And then lastly, our time is going to be 6.7 seconds. The next thing I always ask myself, do we have these in the correct units to proceed in this problem? And the answer is yes. Our distance is in meters and our time is in seconds. So I can just solve this formula as is. I don't need to do any unit conversion. So 1,200 meters divided by 6.7 seconds. 1,200 divided by 6.7. That gives me an answer of 179.1. And then my final units are going to be meters per second. So this would be our final answer for this equation. Now, because I'm most likely posting this as a YouTube video, you can also take this opportunity. YouTube has this wonderful feature, if you don't already know, where you can watch videos in 1.5 speed or 2 times speed. So that way, if you kind of already understand what I'm doing, you can watch the video a little bit faster than the normal pace. However, if you're not watching on YouTube, you won't be able to do that. Or additionally on YouTube, you can also slow it down. Remember that you can pause it, you can stop it, try and work these problems by themselves. So make sure you're using your full capabilities of the video that you're watching to be most successful in solving these problems. For the next one, again, if you want to try this on your own, pause the video, try it on your own, see if you can do it. The fastest person at AHS can run 10 meters per second. If they were to run their fastest from AHS to East Sanford Middle School, how many seconds would it take them? East Sanford Middle School is approximately 1,986 meters from Auburn High School. My formula, speed equals distance over time. Line up my variables. It's asking, what is it asking us to solve for? How many seconds? That's time. So we need to know time in this case. It provides us a velocity or a speed of 10 meters per second. And it provides us the distance right there, 1,986 meters. Everything's already in its correct units. We have meters per second for speed and meters for velocity. So we can just start solving for our equation. Now we're solving for time. So we need to get time on a side by itself. There's 2 ways that you can do this. I have found that a lot of my students like to plug in the numbers first and then rearrange for the variable. So we can say like option number 1, that would be going ahead and plugging in the variables. So we have 10 meters per second equals 1,986 meters divided by time. Now, anytime you have a variable where you're solving in the denominator like this, and you have an equation with just 3 variables like this, you can just simply swap these two out. Okay, so we can just say that time equals 1,986 meters divided by 10 meters per second. That is going to give us a value of 198.6. Meters cancels out, and it leaves us with seconds. So 198.6 seconds is going to be our answer here. In terms of the second way that you can do it, okay? So instead of using this trick where you're actually solving, or excuse me, instead of using this trick up here where I've kind of circled in green, where I just say, hey, flip-flop these numbers, you can do that based off of their position. Let me show you how you actually rearrange to solve for these variables. All right, so we're trying to get time on a side by itself. The first thing I want to do is I want to multiply both sides times t. And I know this seems counterintuitive because you want to get on a side by itself, but if you divide out distance first, you're going to be left with 1 over t, which some people don't really like dealing with fractions. So multiplying by t is going to allow us to not have to look at a fraction type expression. Multiplies both sides by t. This cancels t out. Our new formula is TV equals D. Again, we're trying to get t by itself, so we need to divide both sides by d. That cancels out the, and that gives us distance equals, or excuse me, time equals distance over speed. And that would be 1,986 meters divided by 10 meters per second. This is the exact same thing as what I just did up here. Okay, guys, this is the exact same thing. I'm just showing you how I got that way. And so our answer is still going to be 198.6 seconds. However you want to do it, as long as we're getting the same answer, there's no problem there. For our next problem, we have a football player traveled 78 yards in about 12.2 seconds. What is his average speed? There's our equation. Line up our variables. Now it's solving for speed, and speed is going to be our v variable, so we put a question mark there. In terms of distance, it says 78 yards. Remember, we don't want yards, we need meters in order to solve this. So we're going to use this 71.3 meters here, and it even tells you its distance. And then lastly, it's seconds, so it gives it to us in seconds. So there's no problem there, we don't really have to unit convert again. So we can set this up. Velocity equals distance over time. Put in our distance value, 71.3 meters, divide by 12.2 seconds. This gives us a value of 5.84 meters per second. Question number 4. A pitcher in MLB, Major League Baseball, throws the ball 8.4 meters from the mound to the plate. On average, it only takes 0.279 seconds. What was the speed of the ball in meters per second? Of course, here's our equation. It gives us 18.4 meters, tells us this happens in 0.279 seconds, and it's asking what is the speed. Again, this is one of those straightforward ones. So 18.4 meters divided by 0.279 seconds. We can put that in our calculator. And we get a value of 65.95 meters per second. Our last problem. An average soccer kick moves at a speed of 25.99 meters per second. If the person is 9 meters from the goal, how many seconds does the goalie have to make the save? So of course he's trying to prevent this goal from going in. Speed equals distance over time. Line up our variables. What is the question asking for? It's asking for seconds. So we put a question mark for time. It tells us we have a distance of 9 meters and a speed of 25.99 meters per second. Remember a few problems ago, we're still solving for time. So if you're solving for time, you can just simply use time equals distance over velocity. I showed how to rearrange it a few slides ago. We can plug in our values because all of our units are correct. So 9 meters divided by our velocity, which is 25.99 meters per second. Put this value into the calculator, and it's going to come out to be 0.346 seconds, which that is not a lot of time, so I don't think the goalie is going to be able to save this shot. But here is our value for the question nonetheless. So anyways, guys, if you have any problems, please reach out to me. I'm more than happy to help. I plan on making all of our calculation videos this way for us. So if you need anything more, please just let me know. I am always just a message away on Schoology. Anyways, good luck, guys. Make sure you're staying on top of your work. I miss you all.